Okay, students, we're going to go over a few problems from your assignment. What I have here, these are problems just like yours, just different numbers. You'll see that if you look through this assignment, there's basically two problems of each type here. And so I'm going to go through one of each type, and then you have obviously an example of how to do all of them. Okay, so the first one, we're going to find the volume of a rectangular box or rectangular prism. And this time, instead of giving you the lengths as only numbers, they give them to you as algebraic expressions. Okay, so you can see that this length is 3a plus 4, this length would be 2a plus 8, and this length would be 2a plus 4. Okay, it doesn't matter whether it looks like it or not, we go by the numbers, as we do in geometry all the time. Okay, so what it comes down to is, can I multiply these three binomials together? So I'm just going to write them out here, 2a plus 4, 3a plus 4, and 2a plus 8. Okay, so the one thing to realize is, and if you want to put length, width, and height, that doesn't matter. We know the volume is length times width times height. You just multiply these three together. It's that simple. So the question is, do you know how to multiply your binomials from Algebra 1? Okay, this is Algebra 1 review. The only part that here is geometry is, do you know to multiply length times width times height? That's the geometry part. The rest of it's Algebra 1. Okay, some of you have forgotten this. So I'm going to review. When I have three polynomials and I multiply, I only can multiply two at a time. It doesn't matter which two I choose. Okay, it's up to you, but you only can do two at a time. So I'm just going to go ahead and do these first two, get that answer, and then multiply it by the third one. Okay, it doesn't matter which two you choose to do first, but you can't do all three at once. Okay, there'll be somebody, at least one person, that doesn't watch the video and does all three at once, makes up their own way of doing math, and is going to miss it. Okay, all right, so you might have learned box method, different, FOIL, etc. I use what's called the vertical method, like you do multiplication in elementary school. So I'm going to do that. So I have 2a plus 4 times 3a plus 4. This would be the same thing as if I was to multiply 23 times 34, for example, from elementary school. Okay, and multiply that out. Okay, multiply the 4 through times 3, and then the 2 in the first row, and then move in a space, for example, to line up your like terms, and then 3 times 3, and then 3 times 2, and then add them together. Okay, that's what we're going to do right here. So 4 times 4 is 16. We just don't do any carrying here, like you would up here. We don't do carrying, we just write down the number itself. Then I have 4 times 2a is 8a. Okay, if you want to put the plus, because it's plus 8a, you can do that. Just make sure you know what the sign is for it. Then I do 3a times 4 is 12a. Of course, I can put a plus there because I know it's positive 12a. And 3a times 2a is 6a squared. Okay, and then I'm going to add straight down. Notice it lines up my like terms already. So I have 6a squared plus 20a plus 16. Okay, now I take that answer and multiply it by the 2a plus 8. So I'm going to do that up here. Okay, 6a squared plus 20a plus 16. I'm going to multiply by 2a plus 8. Okay, we do the same steps again. 8 times 16 is 128. That's a positive. Plus 8 times 20a is 160a. And 8 times 6a squared is 48a squared. Now I go ahead and do 2a times 16 is 32a. Again, I'm lining up like terms. Okay, that way I just have to add straight down when I'm done. 2a times 20a is 40a squared. And 2a times 6a is 12a cubed. Okay, And now I just add straight down like I would have done up here in multiplication as well from elementary school. So plus 128, and here we have plus 192a, and here we have plus 88a squared, and we have our 12a cubed out front, and that whole answer is cubed. We don't know what the units are, but we know it's volume. So we put cubed, and there you go. There is your final answer. Okay. Just give me a chance to write that down before I go on to the next problem. Okay, here we go. Next one. Just so you know, this is often a highly missed question on the test because kids can't multiply still and add still. Okay, you have all the example. Clear as can be right there. Okay, algebra 1 is what this is. Okay, all right, number 8 now. And of course you have another one like this. Number 4 is also like it. All right, line segment AB, whose endpoints are 2, -2, and 12, 16, is the image. So this is the image of CD after a dilation of 1/4. So 1/4 means it got smaller, right? This image got smaller. So that means if I find that and then center at the origin, okay? And that's key as well, center at the origin. That just means I do the reciprocal. This got 1/4 smaller in length, okay, when it's centered at the origin. So therefore, to get back to the original length of CD, I have to take this length and multiply it by 4, reciprocal. That's simple. So now this again is distance formula or Pythagorean theorem. Remember, Pythagorean theorem and distance formula are the exact same things. Get that answer and then multiply by 4 to find the length of the pre-image. Okay, so I'll show you distance formula. Okay, I subtract change in y. 16 minus a minus 2 is 18. I'm just saying it verbally, what I did. 16 minus 2, remember subtraction of my y's. Squared plus subtraction of the x's squared. 12 minus 2 is 10 squared. Okay, 18 squared is 324 if you have your Pythagorean, or if you have your squares memorized. 324 plus 100 is 424. So then you can work on your mental math. Obviously, most of you are going to have to use a calculator. Okay, and now what I would do is I would reduce this radical, take that answer, like I said, and multiply by the reciprocal of 1/4, which is 4. So multiply by 4 afterwards. So I can see, I could start with a small one if I wanted to, and see that 4 goes into 24. So I know 4 is going to go into it. So we're going to have to take, and the square root of 4 is 2. And 4 goes into this 106 times. Okay, and 4 does not go into that because 4 doesn't go into 0.6. Let's see, half of that is 53. 53 is prime, so that is it. 2 times 53 is 106. Both those are prime, so it's not going to be a perfect square that goes into it. Okay, so this simplifies to 2 times the root 106. Now I take that answer and multiply by 4, or multiply by 4. So I multiply by 4, I'm only multiplying by the number outside here. So 4 times 2 is 8 root 106 is my answer. Okay, and I can just put U for units. Okay, now you could have gone ahead and done 4 times, well, the one thing you have to be careful with this, you can't just do 4 times this underneath the radical here, because remember that really means you're multiplying by the square root of 4. If you're multiplying 4 times square root of 124, Remember, the square root of 4 is only 2. So really, if you want to multiply this times something, you'd have to have square root of 16, because the square root of 16 equals 4. So then you'd be multiplying 16 times 424, getting a huge number, and then needing to reduce that radical down to 8 root 106. Much simpler to reduce it first, and then just take that and multiply by the 4 out front. Coefficient, whatever the coefficient is, 4 times 2, in this case 8. All right, next. The line 3y equals negative 2x plus 15 is transformed by dilation. So now we're going to talk about dilations again. We talked about dilations first semester, now we're talking about dilations of lines this time. We did not do dilations of lines in the first semester. I put it in here in the second semester because it was in mod 4 in the book. Instead of bringing it in the first semester, plus it makes you do review if we were doing the DCAS reviewing of dilations as well again. Remember, dilation gets something bigger or smaller, okay? If it was exact same, remember that ratio is 1, right? The dilation would be 1. That usually is never the case, but if they were to ask that, we've talked about that before, okay? So here, it says it's transformed by dilation of 5. That means it's going to get 5 times bigger than this, centered at the origin. The key is it's centered at the origin. Okay? Now it says, what's the equation of the image? So the first thing I need to do is I need to solve this for y, because I need to get down to slope-intercept form. So divide each term by 3. I get y equals negative 2/3 x plus 5. Okay? So that's the equation of this line. These are very simple questions, just so you know. You just got to remember 2 rules. When it's centered at the origin, first off, whether it's centered at the origin or not, the slope never changes. So the slope for the image will also be negative 2/3. Remember, we talked about when we gave you notes before on dilations. Remember, we had the property of parallelism. So that means the image and the preimage are parallel. What does parallel mean? Same slope. Okay, so that's review. That's why I just told you. This slope will never change. What will change is the y-intercept. That's it. Now, since it's centered at the origin, all I do is multiply that y-intercept by, in this case, 5, or whatever happens the dilation to be. So 5 times 5 is 25, and that's it. I'm done. Negative 2/3 x plus 25. Very simple. So you got to memorize, slope stays the same. I multiply the y-intercept by whatever the dilation is. If it was 1/5, it would be multiplying 5 times 1/5 would be 1. That's when it's centered at the origin. Okay? That's why I said that there. Okay, so if I look up over here, 4 is the, 3 is the same as we had done before. Find this length, multiply by the reciprocal, in this case 4 again, just randomly generated 4. Okay, 4 is one just like we just did, so you get divided by 2, get down to y equals, and then multiply, the slope stays the same, multiply the y-intercept by the 3. That's what we just did. Okay, next type, right here. We have a point, preimage point. What are the coordinates of this under these 2 transformations? Remember, I can't call it an isometry, because isometries, what do you remember about isometries? The preimage, the image remain what? Starts with C. Congruent. Well, when I do a dilation, does it remain congruent? No. This y equals x remains congruent, but this makes it get bigger by 7 times. So it's not an isometry or rigid motion. This combination is a transformation. Okay, transformations are all your isometries plus your dilation. Okay, in order to be isometry or rigid motion, it can only be a reflection, rotation, translation, or glide reflection. The image and the preimage must remain congruent. Okay, so remember in function notation, we see that little circle there up in the middle like this. That means do this following, or that means following this. So that means you do this one first, this one second. So you should already have memorized now. What do you do for reflection over the line y equals x? All I do is switch x and y. Okay? So you can write that if you want to, xy becomes yx. That would be your work. Okay, when it comes to the test. Okay, so just this sheet right here, this is more of your, you're going to have your volume and area sheets that we just did this week or last week, depending on when you watch this video. And then this sheet, that's what is made up of your test at the end of the first week in May, depending on when you watch this video. So it's either next week if you're watching the video this week, or if you watch the video on the day that it's assigned, which is Monday, then it'll be the end of that week right there, Friday. Okay, so therefore -4, 6 becomes what? 6, -4. That'd be the first image. And now it says take that and do a dilation 7 times. So all I do is multiply each of these coordinates by 7. That's simple. So it gives me 42, comma, -28. And there's my answer. Okay? All right. 2 more, and we're done. Okay? So, number 6 here. What is the slope of the image of the line after dilation of a scale factor of 9 centered at the origin? Again, key is it's centered at the origin. So if we were in class and we had done everything in regards to dilations with lines, I would have had you would have done some problems that were where the center was not at the origin. I might go ahead and just show you something like that. I'm not going to do it on this video. You're not going to get tested on it. So you're only doing one center at the origin, because like I said, your test is going to look like this, just different numbers, along with your area and volume worksheets that you did. Okay, so what's the key? What's the slope? What do we know that doesn't change in all dilations? The slope. So therefore, it doesn't matter what all this says right here. It's worthless, because the slope doesn't change. They're trying to trick you. Okay? And somebody who doesn't watch the video, doesn't take notes, is going to sit there and take and multiply the slope by 9 and get it wrong. I'm just telling you that. Okay? So, therefore, the answer is, what's the slope? M equals -4/9. And we're done. That's simple. Okay. Now we're reviewing circles. Find the center and radius, complete the square. Find your center and radius again. Exact radius means reduce the radical if it reduces. Okay, this is the last type. Okay, so remember, we get our x's and y's all to one side. We want them to be positive. So x squared is positive, we're moving the x's and the y's over the left side, leave the constant over on the right side. So I have x squared. And then since this is minus y squared, it becomes plus y squared. Oops, I forgot. Here's my plus 6x. So I'm going to minus the 6x. I group them together. Plus the blank I got to find for the c. Or that's your c. You're finding complete the square. And then plus my y squared. And there's no other y to bring over. So that means I'm going to have to complete the square all for the y. So we know the center, the y coordinate is 0, equals 35 plus that blank, whatever I have here, I must add over there. Okay, and how do we get this again? You should have it memorized by now. We always know it's 1/2 of b, quantity squared. Remember, here's my b right there. What's half of -6? -3. What's -3 squared? +9. So I'm adding 9 to the other side. Okay, that should be a simple review now. You've done so many of these. And so what is this completed square over here? This would be x, and it's always half of b, so it's -3 squared plus y squared equals 44. I'm going to put that over here, 44. So there's my standard form equation. And then to get my center and radius, we know the three words: opposite, opposite, square root. Every time. So the opposite of -3, +3, the opposite of 0 is still 0. And I don't write down the square root of 44. I'll put that off to the side here because I need to reduce. What perfect square goes into 44? 4 does. 4 times 11, and the square root of 4 is 2. So the answer is 2 root 11. Okay, and so that takes care of every type problem on here. You got 2 of each type. So you can see there's a slope one again here. In number 11, you do your complete square again on this one. Okay, and that will do it for this video. So this is the last part that's on your test at the end of the first week in May. You'll have this plus your area and volume worksheets that you did.